yes, today we are going to learn an extremely important topic of quantitative aptitude, HCF and LCM. This topic is asked regularly in SSC, banking, railway, NDA, UPSC, state PSC and many other competitive exams. So let's understand the concept clearly from the fundamental level. Content of this topic, sir. First we will discuss what is HCF, how to find HCF, HCF by prime factorization method, HCF by division method. Then we will discuss about LCM, how to find LCM, then LCM by prime factorization and division method. Then we will discuss important points, relationship between HCF and LCM, HCF and LCM of decimals, and HCF and LCM of fractions. Then we'll do a quick recap. So let's get started. First, what is HCF? HCF means highest common factor. It is the largest positive integer that divides two or more numbers without leaving a remainder. For example, say 12 and 15, HCF of 12 and 15 will be 3 because the highest number that can divide both 12 and 15 is 3. So if we take 12 and another number 15, the number which can divide 12 are 2, then 3, then 4, then 6. The factors of 15s are 3 and 5. It can divide 15. So what is the common highest factor? Common factor is 3 and here it is 3. So highest common factor is 3 here. So here are the methods we can use to find HCF of given number. Prime factorization method and division method. HCF by prime factorization method. In prime factorization method, what we have to do, we have to individually find out the factors. Now here we can see 8, 12 and 16. Say 8, how we will find out the factors? Say this is the prime number, less prime number 2. So 2 into 4 is equal to 8. Then again we simplify it. So what you will get, 8 equal to, the factors are 2 into 2 into 2. Now another number is 12. So 12 also similarly will take the factors. 2 into 6 is equal to 12. 2 into 3 is equal to 6. So 12 will be 2 into 2 into 3. Then we'll find out the factors of 16. 2 into 8 is equal to 16. 2 into 4 is equal to 18. 2 into 2. So 16 will be equal to 2 into 2 into 2 into. Now which are the common factor here? So here how many 2 is there? 3. Here 2. Here 4. So number 2 will be common here. Then here is 3. 3 is not in 8. 3 is not here. So if we see only 2 into 2, 4 is the common in all the numbers. So that is the highest common factor here. 2 into 2 equal to 4. So 4 is the greatest number that can divide 8, 12 and 16 without having a remainder. Okay, let's see another example, that is 24 and 16. So similarly, 24, we will find out the factors. 12, 6, 2 into 3. Then another number is 36, 18. We have to simplify like this way, 3 to 3. So 24 equal to 2 into 2 into 2 into 3. Then 36 equal to 2 into 2 into 3 into 3. So which numbers are common here? 2 into 2. Then here is 1 3, here is 1 3. So HCF will be, which are the common? 2 into 2 into 3. So this will be 12. So this is HCF for 24 and 36 will be 12. 12 into 2 is equal to 24. 12 into 3 is equal to 36. It is the highest number that can divide 24 and 36. Let's take another question. Find the greatest number that will exactly divide 200 and 320. Find the greatest number that can divide 200 and 320. So greatest number, if we have to find out greatest number that will divide 200 and 320, that means we have to find out the highest common factor HCF. So 200, we will make the first find out the factors. Five into 5. 320. So 200 equal to 2 into 5 into 5. So 320 equal to how many 2? 1, 2, 3, 4, 5, 6. 2 and 5. So common factor will be how many maximum 2 here? 3 2. So the 3 2 is there, and 2 5 here, 1 5. So 1 5 is play common. So highest common factor will be into 5. This will be 2 into 2 4 into 2 8, 8 into 5 40. So 40 is the greatest number that can exactly divide 200. 40 into 5 is equal to 200, then 320. 40 into 8 equal to 320. So this is the greatest number which can divide 200 and 320. Now we will see another method of finding out highest common factor, that is by division method. So in this method, what we have to do, we have to divide the larger number by some small number, then divisor of the above step divided by remainder. So divisor will be the small number, so that will be divided by remainder. The divisor of step 2 divided by remainder, again keep doing till remainder will be 0. The last steps divisor will be HCF. So let's do this one. 24 and 36. 36, 24. So here large number is 36 and smaller number is 24. So we'll divide 36 by 24. So 24 into 24 is equal to 36. 12 will be the remainder. Now we got remainder is 12, and this is divisor, divisor. Now we will divide with this remainder to this remainder to this divisor 24. 12 into 2 is 24. So remainder will be here. This remainder will be 0. So the HCF will be here 12. So HCF will be 12. This is the method of doing by division method. This is for two numbers, 24 and 36. Let's do another HCF of two numbers by division method. So 70 and 90. Here 90 is the bigger number and 70 is the smaller number. So we will divide 90 by 70. So 70 into 1, 70. So remainder will be 20. So again, then we have to divide 20. We will have to divide 70 by 20. So here 12 and 20 into 3, 60. So 10 will be the remainder. We have to divide 20 by 10 now, because here last divisor was 20. So 20 by 10 is 2. So remainder will be 0 here, and the HCF will be the last divisor. The last divisor will be the HCF. So where remainder will be 0. So here it is 10. So 10 will be the HCF by this method. Hope you understand the process. So we'll move to next. So in case of HCF for more than two numbers, how we will do? Here any two members chosen, say 24, 36 and 48, we will choose any two numbers, and we have to obtain by HCF by previous method of division. By method of division, what we have done last, and then HCF of step 1 and any other number obtained. Then again HCF of step 2 or any other number obtained. So we will have to find out HCF of 24 and 36, say. Then whatever we got from that HCF, and then next number 48 we will have to find out. So we will have to keep, if it is more than 3 number, we have to keep continue till the last step. So in this case, say here 24, 36 and 48. What is this done? First it is taken two number, 24 and 36. Here 24 is divisor, 36 is the larger number. So here HCF is found between 24 and 36 by divisor method, 12. Now 12 and 48 we have considered. So 12 into 4 is equal to 48, and remainder will be 0. So the last step HCF is 12. So the 24, 36 and 48 HCF will be 12 only. Now we will find out the HCF of 15, 40 and 60. So we will first consider two number 15 and 40. Say 40, we'll take 15 into 2, 30, 10. So we have to consider 15, 10 into 1 is equal to 10. So remainder will be 5. So Here remainder will be 5. So divisor 10 will come here. 5 into 10, 0. So last divisor is 5. So here HCF will be, HCF between 15 and 40 is 5. Now we have to do HCF between 5 and 60. So 5 and 60. Now 60 is the large number and 5 is the smaller number. 5 into 12 is equal to 60. So remainder will be 0 here between 5 and 60. So 5 will be the last divisor. So HCF will be HCF 15, 40 and 60 is equal to 5. This is how we will have to do for HCF for more than 2 numbers. First we will do HCF between 2 numbers. We will find out the HCF, and that HCF and the remaining number we have to find out the HCF. Same way, similarly. Now we will discuss about LCM. What is LCM? LCM means least common multiple. It is the least common, it is the smallest or lowest positive integer divisible by all of them without a remainder. Generally, it is used to find a common denominator for fractions or a common reference point for, say, recurring events. Now, for example, say 4 and 6. So multiple of 4 and 6. What is the multiple of 4? 4 into 1 4, 4 into 2 8, 4 into 3 12, 4 into 4 16, 4 into 5 20, like this way. Similarly, multiple of 6 are 6 into 1 6, 6 into 2 12, 6 into 3 18, 6 into 4 24, like, and so on. So what is the least common number which is common to both? So 4 is not coming for 6, 8 is not there for 6, so 12 is common. It is the least common number, common multiple numbers, 12. So in this case LCM will be 12. Now how to find LCM? LCM can be same like HCF method. We can do it by prime factorization method and division method. First we will see by prime factorization method. To find LCM using prime factorization method, we have to factorize each number into prime components, identify the highest power of each prime factor present. We have to find out the highest power of each prime factor present and multiply those highest powers together. This method works efficiently by finding the product of all unique prime factors with their maximum exponents. So highest power factor for each prime number we have to find out each prime factor. Say here example given 12, 16 and 18. So for 12 we have factorized 3. So here see 12, 2 into 2 into 3. So what is the maximum exponent will be? Power of 2 will be 2. 2 into 2 into 3. 3 exponent is 1. So 16 So 16 it will be 2 to the power 4. 18 like this. So 18 we can write 2 to the power 1 into 3 to the power 2. 2 3 is there, so exponent of 3 will be 2. Now LCM will be, what is LCM? Highest power for each prime factor presence. So LCM here will be 2. What is the 2's maximum exponent? Here 2 to the power 2, here 2 to the power 4, here 2 to the power 1. So 2 to the power 4 is the highest. Then 3, here 3 1, and here 3 2. So we will take maximum 3 2. Then another number, is there any other number here? No, 2 and 3. So 2 to the power 4 into 3 to the power 2. So 2 to the power 4 means 16 into 9. So 16 into 9 is equal to 144. So this is how we will have to find out the LCM by prime factorization method. We'll see another one, 12, 15, 20 and 54. So 12 will be 2 into 6, 2 into 3. 15 is 3 into 5. Three into 9, 3 into 3. So we can write 12 equal to 2 square into 3. 15, we can write like this. 20, like this. So LCM will be, so what is the 2's maximum exponent? Here 2 to the power 2, 2 to the power 2, 2 to the power 1. So 2 to the power 2. Then 3, 3 to the power 3. And 5, 5 to the power 1 here, 5 to the power 1 here. So 5 to the power 1. Into 5. So if we multiply this, we will get 540. So that will be the LCM of 12, 15, 20 and 54. Another method we can find out LCM is by division method. In this method, divide the given numbers by common prime number until the remainder is prime number or 1. LCM will be the product obtained by multiplying all divisor and remaining prime numbers. So here one example we have given 20, 30 and 36. Here 20, 30 and 36 we divide. First we take prime number 2. 2 into 10, 20. Then 30, 15, 18. Then again we divide the prime number 2. 2 into 5, 10. 15 we cannot divide, so 15 will be remain same. Then 2 into 9, 18. Again we simplify, dividing by 3. So 5 we cannot divide, so 5 will be remain same. 15, 3 into 5, 15. 3 into 3, 9. So here 2 5s are there, so 5 we can divide. 1, 1, then 3 we cannot, so 3. Now we have to multiply all these numbers, remaining number. 2 into 2 into 3 into 5 into 3. And when we will multiply this, we will get 180. Let's do similarly. 12, 15, 20 and 54. So 12, 15, sorry. 12, 15, 20, 54. So we take it together. This is 12. So first we divide by 2. 2, 6, 15 we cannot divide, so it will remain same. Here we will get 27. We divide again by 2, then we will get 3. We cannot divide 15. This we will get 5. This we cannot divide. Now we will divide by, yes, now we will divide by 3. This is 9. Now we will divide by 5. So LCM will be 2 into 2 into 3 into 5 into 9. So 12 into 45, and we'll get it is 540. So this will be the answer. Now we will discuss some important points. There is an important formula there for the relation between HCF and LCM. And what is the relation? The product of highest common factor HCF and LCM of two numbers is equal to the product of the two numbers. So what it means? HCF into HCF of two numbers, say x and y. HCF of x and y into LCM of x and y equal to x and y. HCF into LCM is equal to product of the two given number, first number into second number. So from here, if we know the two number and HCF, we can find out LCM, or if we know first and second number and say HCF, then we can find out LCM or HCF, whichever required. So here one example, let's the number are 10 and 15, and HCF will be 10 is equal to 2 into 5, 15 equal to 3 into 5. So here HCF will be highest common factor 5, and LCM is 2, 3 into 5, that is 30. So HCF is 5, LCM is 30. So now product of the two number 10 into 15 is equal to 150. Now HCF into LCM will be 30 into 5, that is equal to 150, and product of the two number, that is also 150. So this is the relation. HCF between the two numbers, HCF and LCM of two numbers is equal to product of the two numbers. The HCF and LCF of any two numbers are 63 and 12600 respectively. If any of the two number is 315, find the other number. We know HCF. Now how we will do this one? We know HCF into LCM is equal to say number 1 is x and number 2 is y. First number is x, second number is y. So we know x is given 315. So 63 into 1260 equal to 315 into y. So y will be equal to 63 1260 by 315, and when we simplify we will get 252. Another question, say LCM of two number are 495 and their HCF is 5. LCM is 495, HCF is 5. If the sum of two number is 100, then what is the difference? So if one number is 100, sum of these two numbers, say x and y, two numbers. So x will be equal to 100 minus y. Now according to this formula, 495 HCF into LCM equal to 100 say numbers are 100 minus y into y. In case of x, we written 100 minus y, so 100 minus y into y, so that will be 100y minus y square. So 495 into 5 equal to 2475 plus y square, if we take in this side, minus 100y equal to 0, or we can rewrite it y square minus 100y plus 2475 equal to 0. Now we know the formula, y, if it is ax square plus bx plus c, say this consider ax square plus bx plus c form. So we know the formula of the root, x is equal to minus b plus minus root over b square minus 4a into c by 2 into a. So we use this way, then so here it will be y, not x. So y equal to minus b, b will be here 100, minus b means 100. So 100 plus minus b square, that means 100 square minus 4 into a is equal to 1 here, and c is 2475 by 2 into 1. Here see, you can see a is equal to 1 here, b equal to minus 100, c equal to 2475. If we consider it in the form ax square bx plus c form. So 100 plus minus 100 square minus 4ac, if we simplify it, we will get it root over 100. Then this is 2. So this we will get 100 plus 100 plus 100, 200, 100 plus 10, 110, 110 by 2 and 90 by 2, two numbers. 110 by 10, let's rub it. So one number will get 110 by 2 and another is 90 by 2. So 110 by 2 is equal to 55 and another number will be 90 by 2, 45. So these are the two number we got. And again cross check we can do 55 plus 45, it is equal to 100. So it is okay. This sum is 100, so it is okay. So the two numbers is 55 and 45. So we have to find the difference between these two numbers. So difference will be 55 minus 45 is equal to 10. This will be the answer. Another important point is HCF and LCM of decimals. So sometimes it will be in decimals, then how we will find out. So when it is in decimals, what we have to do, first convert each of the decimal to like decimals. We have to convert decimal to non-decimal numbers. Such a way it will be like decimals. And remove the decimal points and find the highest common factor and least common multiple as usual. So without decimal we will find out. First we will convert to like decimal, then we will take the HCF and LCM, and later we will put the decimal point on this. Once we got the HCF or LCM, we will put the decimal points there finally. So one example is here 0.032, 0.96 and 16. Now here highest decimal point is after decimal 3 numbers. So to make it non-decimal, we have to multiply this into 1000. Then we'll get 32. So each number we have to now multiply by 1000. So this number will become 960, and 1.6 into 1000, it will become 1600. Now we have to find out the HCF of 32, 960 and 1600. So here we have find out 32, we factorized 960 and 1600, and here common factor is 2 into 2 into 2 into 2 into 2. Here 5 2's are there, here also, and here is no 5. So highest common factor will be 2 to the power 5 or 32. Now we got HCF of this number is 32. Now we have to divide this by, because we multiplied by 1000, now we have to divide this number by 1000, then we will get 0.032. That will be the HCF of this decimal. HCF of this number is 0.032. This is the procedure. Another example is 1.2, 0.24 and 6. So here highest decimal number is 0.24. So we have to multiply this by 100. So it will be 0.24 into 100. It will become 24. 1.2 into 100. It will become 120. And 6 into 100. It will be 600. Now we have to do LCM of these three numbers. Say 24, 120, 600. We multiply by 3. So LCM will be all the numbers 2, 2, 3 into 2 into 5 into 5. That will be equal to 600. Now we got it 24, 120 and 600. Its LCM is 600. So we have to finally, for 1.2, 0.24 and 6, we have to divide this by, because we multiplied by 100, so we have to divide finally by 100. So we'll get 6. So 6 will be the LCM of these numbers. So the answer will be 6. That is for decimal. Now how to find out HCF and LCM of fractions. To find HCF and LCM of fraction, use the formula HCF of numerator, say fraction. So we have to use this formula HCF of numerator by LCM of denominators. HCF of fraction equal to, we have to use this formula HCF of numerator divided by LCM of denominators. And for LCM of fractions, first we have to find out LCM of numerators, then HCF of denominators. Now here example, you can see HCF of say 2 by 7, 4 by 3 and 6 by. Now here numerators are 2, 4, 6, denominators are 7, 3, 11. So here we have to first find out HCF of 2, 4, 6 divided by LCM of 7, 3, 11. Then LCM will be, first we will find out LCM of 2, 4, 6 divided by HCF of 7, 3, 11. Whatever the result we will get, that will be the final. So one example here, find the LCM of 5 by 9, 5 by 9, 6 by 7, 9 by 13, 11 by 15. We have to find out LCM. So what we have to do here, so LCM of numerators, then HCF of denominators, So LCM of numerators means LCM of 5, 6, 9 and 11, LCM of 5, 6, 9 and 11, and then divided by HCF of 9, 7, 13 and 15. Here we got HCF of 9, 7, HCF of 9, 7, 13 and 15 is equal to 1, and LCM of 5, 6, 9 and 11 equal to 990. So answer will be 990 by 1, that is 990. This is how we have to do for fraction. We'll do one more. 4 by 9, 10 by 21 and 20 by 63. We have to find out the HCF. So HCF will be HCF of numerator, say n, and LCM of denominators. So HCF of numerator means HCF of what? 4, 10 and 20. So 4 is equal to 2 into 2, 10, 2 into 5, 20, 2 into 2 into 5. So what will be the HCF? Equal to 2 is the common here, only 2 will be the common here. So HCF of 4, 10 and 20 is only 2. Now we have to find out LCM of denominator, that is LCM 9, 21, 63. So 9, 21, 63, we will find out the LCM. Okay. 1 7 7, then we 7 1 1 1. So LCM will be 3 into 3 into 7, that is 63. So what will be the HCF of 4, 9, 10, 21 and 26? Say we put it here. HCF of numerator is 2 and LCM of denominator we find out 63. 2 by 63. So this will be the HCF of 4, 9, 10, 21. So answer is 2 by 63. This is how we have to find it out. Quick recap. In this session, we have tried to understand what is HCF, what is LCM, how to find out HCF and LCM, and the common points, some important points. So what is HCF? HCF means highest common factor, right? It is the greatest number that can divide two or more given number exactly without leaving any remainder. And in simple word, it is the largest number common to all the numbers. Say 12 and 15. So the highest number that divide both 12 and 15 is 3. So this is the HCF here. Now how we will find out HCF? HCF can be found out by two methods, prime factorization method and by division method. In prime factorization method, we have to break each number into prime factors. Say 12 and 15. Say 12, we have to break it, factorize it. So 12 equal to 2 into 2 into 3. Now 15, 3 into 5. 15 is equal to 3 into 5. Now if we see what is the common factors here, 3. It is 3. So this is the highest common factor. So individually we have to find out, we have break each number into prime factors. Then we select only the factor that are common in all numbers. And if it is more than one common factor, then we have to multiply that two common factors. Another method is HCF by division method. In division method, it is a faster method, usually used for large number. We divide the large number by smaller number, then divide the divisor by the remainder. Continue this process until the remainder becomes 0 and last divisor of the HCF. That is called division method. Quick example, say 24 and say 36. So 36 by 24, 12. Now 12 is the remainder here, divisor was 24. So 12 into 2 is equal to 24. What is the last remainder will be 0 here. Last divisor is 12. So that will be the HCF. This is how we have to do by division method. And in case more than two number, say 24, 36 and 48. First we will find out the HCF of 24 and 36, any two number. Say we got 12. Now this HCF 12 and 48, again we do the same process. And whatever the HCF we will get between 12 and 48, that will be the final HCF. This is for more than 2 numbers. For LCM is the least common multiple. LCM is the least common multiple. It is the smallest number that is exactly divisible by all given number. Unlike HCF, which focuses on division, LCM focuses in multiple. Now LCM can be find out by prime, similarly same like HCF, prime factorization method and then division method. And in prime factorization method, we have to consider the highest exponent highest power and multiply them to get LCM. Say 12 and 15 say. So 12 is equal to highest power is 2 for 2, then 15 3 is 1 5. So here LCM will be first 2 with highest power, then 3 only 1 both, and 5 only 1. So 60 will be the LCM here. And divisor method for the LCM is like this. Say 12 and 15, 2 numbers is there. So it will division by 3, 5. So LCM will be all the numbers here. 3 into 4 into 5 is equal to 60. This is the way. Now some important formulas are there, that is HCF into LCM is equal to if it is 2 number 1 into product of the 2 numbers. So HCF and LCM of 2 numbers is equal to product of the 2 numbers. This is one important formula. If we know HCF and we know the 2 numbers, we can find out LCM. Similarly, we can find out HCF, or if we know HCF, LCM and one number, we can find out another number 2. Another important formula is HCF and LCM by decimals. In decimals, what we have to do, so first we have to convert decimal into whole number by removing decimal places. We have to convert it to like decimals, and then we have to find out HCF and LCM of the whole number, and later we have to convert the whole number into decimals. Then another one is the HCF and LCM of fractions. So here important formula is, say HCF will be HCF of numerator by LCM of denominator, and if we have to find out LCM, first we have to find out LCM of numerator, then HCF of denominators. So this way we have to do for fractions. So that's all. Thank you for joining this HCF and LCM session. We explored concept and various questions related to HCF and LCM. If you found this session helpful, please like, share and subscribe. Thank you.